this. This is just some denser medium. Okay, which is mu d, and this is some rarer medium. So then the rarer medium refractive index is mu r. Okay, so denser medium and rarer medium. Good evening, sound problem. All of you able to hear me or not? Sandhya, you are able to hear? Vigneshwar, Sandhya. Navesh is talking now? Are is okay? Okay, good. Audible. Yes, two people are answering. Soumya, my voice is not clear. Soumya, once you check your internet connection, maybe because remaining people are getting the audio properly. Vivekananda, I think it's okay, right? Okay, Prabhu. Just give me 1 minute, we will get started. Okay. Further, now you verify my voice. Is it okay? Vijayeshwar is okay. Soumya clear? Okay, very good. Nice. So when ray goes from denser to rarer, we know critical angle. What is the critical angle? I represent with theta c. Okay, this is the symbol I wrote. They asked us. If anyone copied this, okay, just verify your notebook. Then in the notebook you will find out this is the critical angle. Okay. Some people write down simply c also. Critical angle we write down with the c or theta c. Different people will follow differently. Obviously not audible. Obviously verify yours. I think it is audible to remaining people. Obviously check from your end. Soumya, is it okay now? Soumya, Pardo. Audible. Okay, very good. Okay, so critical angle we represent with theta c or c. Then what is the sine theta c is equal to? Sine theta c is equal to mu r by mu d. Rarer medium refractive index by denser medium refractive index. So even I told that it is also equal to 1 by c. Okay, sine c is equal to, or sine theta c is equal to 1 by mu. Sine c is equal to 1 by mu also will write down. People will write down as 1 by mu. So why they will write down as 1 by mu? Whenever you are writing 1 by mu, that means it is from the air to some medium or medium to air. Okay, Vijayeshwar not required. See, no need to remember any values. Vijayeshwar is saying that critical angle for diamond is 24.4 degree. So not required, that no need to go for any informative things. You try to understand the concept. Okay? So information based questions they don't ask. What is the value of a carbon? What is the value of a diamond? What is the value of a glass? They don't ask those values. They'll ask you how the refraction is happening. Okay? So whenever you are writing 1 by mu, that means it is some medium to air. But in general, I am writing as denser medium to rarer medium. Okay? So let us say rarer medium is air. If rarer medium is air, then rarer medium refractive index is 1. Denser medium refractive index I am taking some mu. Okay? Now if I am keeping a one source here, this is the source of light. Source of light, simply I write down as bulb. I am keeping the bulb inside a water. Imagine that this is water. Okay, this is the bulb. Inside the water, I am keeping a bulb. Then what happens? One ray goes straight without any deviation. This is called as normally incidented ray. What is called as normally incidented ray. So this ray is exactly perpendicular to surface. Then it won't deviate. It will go undeviated. Right? It will go undeviatedly. Now I am taking the one ray which is incidented exactly at critical angle. Suppose exactly at critical angle it is incidented, because different rays will incident. Already we discussed in the last class. Different rays will incident at different points with different angles. Right? As you move from this point away, then what happens to the angle of incidence? Angle of incidence will increase. Okay, at some point it will be equal to what? Theta, critical angle. Then how the ray will goes? Ray will grazes the boundary. The ray goes along the boundary. Okay, ray will go along the boundary. All of you following? Tardu, Sandhya, everyone. Okay, right? If any ray which is falling beyond that, it will have more angle of incidence. This angle of incidence is less, this angle of incidence will be more. Then here, angle of incidence is more than critical angle. When angle of incidence is more than critical angle, what will happen? Ray will reflect into the same medium. It won't come out. Exactly, Dipti, correct. Total internal reflection will happen. Even in the last class also we discussed. It is so many days happened, no? Like 3-4 days happened already. Right? So that's why I'm just repeating again, one by one, point by point. So this is the point where you'll find the ray finally. The beyond this all points rays will go out. Okay, from here to here refraction happens. From here, everywhere total internal reflection will happen. Okay, if you see the point, if you see the locus of all these points, locus of all those points, it will form a circle. So rays will come out of that circle. So rays will come out of that circle. This is called as what? Circle of illumination. Okay, this entire circle is called as what? Circle of illumination. You will find the light is coming out from the circle. Exactly, Dipti, correct. Dipti, perfect. Okay, na? So any ray which is falling beyond this, then will total internal reflect. Okay, this is little beyond to your total internal reflection. Okay, this is not in your textbook maybe. Okay, but it is a little good to learn. Okay, always little beyond the textbook. Okay, so I think you might have gone through the total internal reflection. Now we are going to what? We are going within circle of illumination. Okay. Now the question is, what is the area of this circle? What is the radius or area of the circle? Either radius or area I want to find out. How to find out that value? Okay. If anyone want to copy, I ask for exactly. Sharon is correct. But what is the R value? Okay. So for that, copy this diagram if you want. So I'll move to the how to find out the radius or area of circle. We will discuss the area of the circle or radius will find. Okay. A little calculation is there. Already we use the critical angle also. Let me see. First I'll discuss, then I'll search for the video. Dipti, okay? I try to show the video. Okay, now go down. Okay, once verify the diagram what you have drawn. So this is the Water with refractive index mu. Let us see. This is the air, top of air, and what is the refractive index is 1. 1 is the refractive index. Now we are keeping a one bulb. We are keeping the small bulb inside. Okay. Now we know that this is the ray undivided, and this is the ray. Angle of incidence theta c, and here raising will happen. Okay, we require this is the point. This is the point, and locus of all the points having the theta c is angle of incidence. We are taking all the points which are having the angle of incidence as theta c. Okay. So if I follow that, and this is the what? Radius of the circle. This is the theta c. Then this will be theta c again. Corresponding angles, right? If this is theta c, this also will be theta c. Now suppose that depth of the bulb or source of light, depth of the bulb is d. D is what? D is depth of the bulb. Bulb is kept d depth inside the water. All of you okay? D is the depth of the bulb from the surface. From the surface, at a depth of d, we kept the bulb. All of you understood this theta c, right? Angles are same. If you have any doubt, let me know. Now we want to find out R value. Now you can see a triangle. You can see a triangle something like this. This is the radius R, this is the depth d, and this is the critical angle theta c. Angle is theta c. Okay? Understood? Now, what is the relation between the R, D, and theta c? Anyone? Which to be applied? That is okay, Sharon. But in terms of angle, no? Very good, Vishnu. Dipti, not Pythagoras. We don't know what is the hypotenuse. Hypotenuse, we don't know. We know the angle. We know the two sides. Angle and two sides. Then sine or cos to be applied. Or sometimes we can apply the tan also. It depends on what sides you know. As we don't know hypotenuse we don't know. That's why we cannot apply sine or cos. We can apply, like again you can find out the hypotenuse and you can do it also. That also you can do, no problem. Even if you can apply the Pythagoras also, but the straightforward way of solving the mathematics, you know one angle, you know the two sides, then you can apply the tan concept. Opposite by adjacent, very good, correct. Psi, correct, very good. Or else from the hypotenuse also you can do it, no problem. Suppose what is the hypotenuse value? But I want to find out R value. Okay, so for that, what is the best way? I'll go to tan theta c. What is tan theta c value? In the diagram, what is tan theta c is equal to? Opposite side, which is R, by adjacent is D. You have to see the side which is opposite to angle, and adjacent is D. Correct, sure. Critical correct. Very good. It is R by D. We want R value, where R is the radius of the circle. As R is the radius of the circle, so R value I can write down D into tan theta c. R value I can write down D into tan theta c. Okay. Then R is equal to D into what is tan theta c value? We know sin theta c value, which is equal to sin theta c is equal to 1 by mu. If sin theta c is 1 by mu, no? What is the tan theta c value? All of you try. It's a good mathematics from your understanding. We know the sin value. We want to find out the tan value. How to do it? We know the sin value. We want to find out the tan value. Anyone? Sin value we know. Tan value I want to find out. To find out that part, what I am doing is I am taking one perpendicular triangle. Okay, I am taking the one perpendicular triangle. I know sin value. I want to find out the tan value. Okay, Akhil. Vishnu. Okay, correct. Vishnu has given correct answer. Very good. Now I am taking this is the theta. Let us say, for example, I don't know what is the angle. I am not drawing this diagram. This is not a triangle drawing again. This triangle is different from this triangle. I am drawing the sine theta c triangle. For sine theta c is equal to 1 by mu, I am drawing the triangle for them. Don't confuse with this triangle, okay? Tejas, understood? Tejas, are you listening? Tejas Kumar Reddy. Okay. So sine theta c is equal to 1 by mu. So from that, I want to draw a diagram so that I can find out the tan theta c. Okay. Then let us say this is the theta c. Then what is the opposite side? Opposite side is 1. Let us say opposite side is 1. Opposite to theta, I am keeping 1. And what is the hypotenuse value is mu. Mu is the hypotenuse. Okay, this is the conversion of sine to triangle. When they give the sine angle, cos angle, tan angles, you can convert them into triangles. Okay. So opposite side is 1. Hypotenuse value is mu. Then what is this adjacent side? What is this side value? Let us say the side value is x. Then hypotenuse square is equal to sum of squares of sides. 1 square plus x square. Pythagoras theorem applied. Yes, Sharon is correct. Gitka correct. Okay, na? So then I want to find out x value. Then x square is equal to, I can write down mu square minus 1. 1 square is 1. Take the 1 of that side. Then it is mu square minus 1. X square is equal to mu square minus 1. Vishta, very good. Then what is the x value? Root of mu square minus 1. Yeah, we know the x value now. That means we know the one side. Other side is given 1. Hypotenuse also we know. Then what is the tan theta c value? So from this triangle, what is the tan theta c is equal to? Tan theta c is equal to opposite side by adjacent side. So opposite side is 1, adjacent side is x. Opposite side is 1, adjacent side value is x from this triangle. See once. This is the theta c. Opposite side is 1, adjacent side is x. Then it is 1 by x. Okay. Then as it is 1 by x, r value is equal to d into 1 by x value is how much? Root of mu square minus 1. Then what is the r value? D by root of mu square minus 1. R value is equal to what? D by root of mu square minus 1. Clear? So then what is the radius of the circle? Radius of the circle of illumination. D by root of mu square minus 1. Where what is the D? D is the depth of the bulb or source of light which is kept inside the water. Or you can say denser medium. Denser medium or what you can say. Okay. Any doubt? Area will be pi r square, yes. On which situation ray does not deviate. If mediums are same, medium is same, then ray does not deviate at the same time. For normal incidence, see it this way. This ray is incident at 0 angle. If angle of incidence is 0, then it will refract at 0 angle, then ray does not deviate. Sharon, understood? Ray does not deviate when angle of incidence is 0. That's called as normal incidence. Clear? So write it down. If you have any doubt, let me know, I'll discuss. Completed, very good. Okay, all of you understood? If you have any doubt, let me know. I'll explain. Don't worry. We have a lot of time to learn the things. R by D is equal to 1 by X. R by D is equal to 1 by X. Yes, you can write it. R by D is equal to 1 by X also. You can write it. You can compare both the triangles. Definition of circular illumination is the circle through which rays will come out. The circle through which rays will come out. You can write down that. There is no proper definition. It's a simple topic. Okay. Sanjay copied that? Okay, good. Ignesh, switch on your video. Ignesh. Okay, finished it? So next we discuss, which is one part of your textbook, that is Prism. I think all of you gone through Prism, right? How many of you know Prism? How many of you know Prism? Okay, Sanjay, you know it, very good. Who else? Sharantesh, you are having. Is Prism is there in state board? I think it is there in the CBSE, no? What about state board? Okay. Narasimha, you also know it. Very good. Ignesh also know it. Very good. Sai, correct. Some sort of. It will disperse the light. It's also in the state board. Okay, good. So today we discuss about Prism so that it will be a good revision for your board also. So also in state board, correct. So let us go with Prism. Okay. So Prism will have two refracting surfaces. Let us say usually this is the Prism. Prism will be something like this. I don't know how many of you have seen the Prism. Have you seen the Prism? Okay. Very good, Dipti. So I am having some objects in this room. So I don't know, you are able to see this or not? See once. This is an equilateral prism. You can call this one as exactly. You can call this one as prism also. Okay, you can use this one as a prism. Like this is the one surface. Okay, I'll show you. This is the one surface. Okay, you are able to see now. This is the one surface and this is another surface. So this is the thing you can take. Some sort of prism. See, one side is not shiny. This side is not shiny. But this side is shiny. Got it clear? This side is shiny. So this is called refracting surface. And opposite, one more side is there. This is my thumb. I'm keeping thumb sequence. This is one surface and this is another surface. These are the two surfaces. You can see. This is the one corner. Okay? Got it? These two are refracting surfaces. Okay, na? So like that, usually whatever base is there, let us go with the base. See, this is the base. Usual base is not refracting surface. One side will be refracting surface, even other side also refracting surface. There will be two surfaces, refracting surfaces. The block of glass or material having the triangle basis. Yes, sure, we can take that one. Just waiting on the correct. Okay. So prism will have two refracting surfaces. Let us say this is the prism. This is the light. Light is incident on one surface. This is the one refracting surface. This is the other refracting surface. These two are refracting surface. The angle between these two is called as refracting angle. Refracting angle of prism, but this is very less used. What A is called as refracting angle of prism. To confuse you, sometimes they use this word. Otherwise, the regular term is A is called as angle of prism. What A is called as angle of prism. Angle of prism is angle between two refracting surfaces. Angle between two refracting surfaces is called as angle of prism. No. Tejas, don't confuse. Angle of pyramid is something different. It's not angle of pyramid. Pyramid is different. Pyramid is always meet at one point. It's not like always meeting at one point. Pyramid is different from prism. Prism and pyramid is not same. Pyramid will have four surfaces and one base. One base with four surfaces. That's called as what do you say that? Four triangular surfaces. That's called as pyramid. This is okay. This pyramid is different from prism. Huh? Now we can make a one normal here. What is the normal? Perpendicular to this surface. This is the normal. Then what is this angle is called as? Angle is called as angle of incidence. Let us say I1. I1 is the angle of incidence. Then it will refract. Okay? Refract into the prism. Obviously, angle of refraction is less. See once. Angle of refraction should be less. Why? Ray is going from rare to denser. Let us say this is the air. Air is the medium. Here, refractive index of the medium is. Refractive index of the prism is mu. Again, the ray incident over here. This is the one more normal. Are you able to see the normals? You are able to see the normal, no? This is the normal. Okay? So this angle, again, this is the angle of incidence. But we are representing with R2 term. Okay, now R2 is the angle of incidence, not angle of refraction. Now ray will come out with more angle. Okay, that is, I am getting a lighting. There is a story behind it. This is the angle of incidence and this is the angle of emergence. This is the angle of incidence and this is the angle of refraction. Okay, we changed the terminology. Correct. Angle between refracting surfaces of the two prism is called as angle of prism. All of you understood the angles? See, I1 is the angle of incidence. Then R1 is the angle of refraction. And R2 is the angle of incidence again on the other surface. Then I2 will be the angle of emergence. Did you know? Angle of incidence won't be equal to angle of emergence all the time. Only one case it will be equal. Not every time. Whenever angle of incidence and angle of emergence are equal, that's called a minimum deviation condition. Okay, now? Now the question is, what is the relation between I1, I1, R1, I2, R2? No. It's not like all cases. It is only for minimum deviation case. Okay. So I'll discuss. Now, what is the relation between I1, R1, R2, I2? How to find out the relation? Let us go with Snell's law. By Snell's law, what I can write down? By Snell's law, I can write down that A refractive index is 1. 1 into angle I1. So 1 into sine I1 is equal to refractive index is mu. What the angle is? R1. Sine R1 I can write down. So Prism, we don't use all these things we are learning. You can use if you want to see the dispersion of a light. If you want to see the dispersion of light, you will use the prism. Okay, Charan, okay? It's not like everything we use. Okay, sometimes we need to. Binoculars is not like for prism. That is for binoculars. Binoculars for, they will be constructed with lenses, so that you will see the magnified and distance also. Okay, na? So this is the one case, one refraction. There is another refraction. What the angle? Angle is R2. Refractive index is mu. And angle is I2. Refractive index is 1. Then what is the other relation I can write down? I can write down other relation. Mu into sine R2 is equal to 1 into sine I2. Okay. So hope you are understanding this. Whoever following the physics classes from the first, I think they can understand very well. Okay. Already we discussed the Snell's law. What we are doing is Snell's law is refractive index of the material into sine of angle at medium is constant. Should be said. Refractive index is 1. Angle is I1. Okay, so 1 into sine I1 is equal to refractive index is mu. Angle is R1. So mu into sine R1. Similarly, mu into sine R2, angle is R2 is equal to 1 into sine A. Hope all of you understood. So from this, what is mu value I can write down? Mu value I can write down sine I1 by sine R1. Here also what is mu value I can write down? Sine I2 by sine R2. Now you can see there is a rhythm. I1 sine I1 by sine R1, sine I2 by sine R2. That's why they changed it. Okay, there will be no confusion. That's why even the triangle of incidence, they have not taken the I2. They have taken as R2. This is the angle of refraction, but they have not taken as R2. They have taken as I2. Okay. Not only that, if you reverse the ray will travel. If angle of incidence is I1, at what angle it is coming out? I2. If angle of incidence is I2, then at what angle it will come out? At the angle of I1. That's called as principle of reversibility. I will explain that part again. Don't worry. Okay, no? That we do. That we try to learn. So from this, what I can write down? I can write down that sine I1 by sine R1 is equal to sine I2 by sine R. Okay. So that is the mu value. Sine I1 by sine I1 by sine R1 is equal to sine I2 by sine R. Don't write down I1 is equal to I2, R1 is equal to R2. If I1 is equal to I2, then R1 is equal to R2. Or if R1 is equal to R2, then I1 is equal to I2. Okay, now any one condition it has to follow. Okay. If anyone want to copy this right now, we will discuss further. Okay, copy this fast. We will discuss further. Okay. So I'll rub this part. I'll keep the diagram. Now the question is, what is the relation between R1, R2 and A? Suppose if I extend this further, and see here. Now, if this is A, now you can see one quadrilateral here. There is one quadrilateral, right? In quadrilateral, opposite angle should be 180. If this is A, then what is this angle should be? This angle should be 180 minus A. So let me name them. Let us say that this is the something like a C point, and this is the D point, and this is the E point, and this is the F point. Now you can see C, D, E, F. C, D, E, F. You can see 4 points, right? Those 4 points will form a one quadrilateral. So there is a one quadrilateral. Opposite angle should be 180. If you add the opposite angles, that should be 180. That's why other angle are taking 180 minus here. But if you add these two, then you will get 180. Now what is the total angle in the triangle? Total angle is 360. That also we know. What is the total angle in the triangle? Total angle in a triangle. 180 Ganesh, okay. Deepthi, correct. Total angle in a triangle is 180, correct? Then there is a one angle R1, other angle R2, third angle is how much? 180 minus 2. If I am adding these three angles, what do I get? I get 180 R1 plus R2 plus 180 minus A is equal to 180 degree. Right? Then 180 will cancel out. Then R1 plus R2 minus A is equal to 0. Then what is the R1 plus R2 value is equal to A. This is the one important relation between R1 and R2. What is the R1 plus R2 is equal to A. Okay. Usually, whenever we take a triangle, prisms, we take the equilateral prism. If I am taking the equilateral prism, if I take equilateral prism, what is the A value will become? A value will become 60 degree. Angular prism will become 60 degree. Okay. Equilateral. Something like an equilateral triangle. Now we want to identify what is the deviation. Deviation by the ray. So this is the incident ray on the prism, but after passing the prism, ray is going in this way. This is the incident ray. This is the emergent ray. Incident ray and emergent ray. Okay. So there is a difference between incident and emergent ray, right? So incident ray is going in one direction, emergent ray is going in another direction. So that means there is a deviation. So we want to see that what is the deviation value. How to see the deviation angle. So now you extend this line. This is the incident light direction. You extend this line. This is the emergent ray line. This is the emergent ray line. The ray which is coming out of the prism. This is the incident ray. The ray which is advancing without prism. Prism thesis on corner. Then the ray will go in this way. Okay. Then angle between these two, whatever the angle between these two lines is there, that we call it as deviation. Okay? Exactly, Charan, correct. Dipti, perfect. Extending the incident and emergent rays will give you deviation angle, correct. Okay? So this is the incident ray. This is the path followed by the ray without prism. If prism is absent, the ray will go in this way. Because of the prism, the ray is moving along this line. Or ray refracted along this way, in this direction. The angle between those two rays we call it as angle of deviation. Okay? Then how to find out the angle of deviation value? Delta value I want to find. So for that, I am taking these two angles. Okay. Then what is the total angle is I1. So here also total angle should be I1. This entire angle, this angle is I1. These two angles should be I1. I draw one more diagram. Okay. So same diagram I am drawing again. Both ray. See, this is the prism, let us say. This is the ray and this is the normal. Then this angle is I1. Okay? Again it is coming out. This is the other normal. This angle is R2. This angle is R1. Now this is the ray. Extending the incident ray. Extending the refracted ray, final ray. Okay, this is the final ray. This angle we call it as angle of deviation. Okay, na? This angle called as what? Angle of deviation. Clear? So then, see, total is I1 and this is R1. Then what is this angle will become? This total angle is I1, this total angle should be I1. So this angle will be I1 minus R1. Just check. Anyone having the doubt? Did very good. Correct. I1 minus R1. So this angle is R2. This angle is R2. Total angle is how much? At what angle it is coming out? At an angle of I2. At an angle of I2 it is coming out. This total angle is I2. This angle is R2. What is the remaining angle? I2 minus R2. All of you see once. I2 minus R2. Did correct? Did correct? Very good. See, total angle is I2. Then this angle also I2. So one angle is R2. Then the other angle will be I2 minus R2. This total angle is I1. Total angle is I1. Then one angle is R1. Other angle is I1 minus R1. So all of you have to keep your one white page and try to draw these lines and angles. Okay, now try yourself, your own. Then you will understand. And wherever you are stuck, that is the point where you didn't understand. All of you are okay with the angles? Now can you tell me what is the deviation value, delta value? I want to see that what is the delta value. What is the deviation angle? Okay, very good. Dipti, once verified. Mahi, yes. Mahi Jibuma, what is your doubt?
Mahi, unmute yourself, ma.
Say, delta value can I say?
Mahi, what you are asking? I didn't understand anything.
Delta value, sir.
Delta value, tell me.
Only delta value only, no, sir.
Only delta value.
In delta minus v is change in velocity, sir.
Why velocity got? Don't get velocity. Mahi, listen to me once. See, if you see this triangle, okay, carefully. Then again, I'm drawing the triangle, see once. I'm drawing the triangle like this. Okay, this triangle I'm drawing. This is the delta. This angle is I1 minus R1. Okay, this angle is I2 minus R2. Okay, two principles you can follow. You can follow two principles. One is called as what? This is called as exterior angle. These are called as interior angles. One is called as exterior angle. Other one is called as both are called as subject correct. These two are called as interior angles, or these two are called as internal angles. This is called as external angle. Mahi, I'm explaining only. So triangle is there. No? In the triangle we are discussing angles. Same triangle I am drawing here. Same triangle I am drawing here. One angle is I1 minus R1. Other angle is I2 minus R2. Other angle is delta, deviation. Mahi, okay? What is this is called as external angle. These two are called as internal angles. Exactly. External angle is equal to sum of internal angles. This is a mathematical principle. In your mathematics, I think you have done it, right? Yes, correct. So delta is equal to I1 minus R1 plus I2 minus R2. That is one way you can do. The other way is, if this is delta, then what is this angle will become? 180 minus delta. One angle is delta, remaining angle will be 180 minus delta. Then in the triangle, total angle should be 180. In the triangle, total angle should be 180. So I am drawing the same path here, differently. Okay, what is the one angle? I1 minus R1. Other angle, I2 minus R2, third angle, 180 minus delta, delta is the deviation. Total angle will be equal to 180. Sum of three angles in the triangle should be equal to 180. Sum of three angles should be equal to 180. Did understood? Very good. Geetika, very good. Then 180, 180 cancel out. Then I1 minus R1 plus I2 minus R2 is equal to, you can write down delta. Delta minus delta. Okay, I'll write down completely. Minus delta is equal to 0 because 180, 180 cancel out. No? Then take the delta on the other side. Then it is I1 minus R1 plus I2 minus R2 is equal to delta. You can solve in this way. Total angle in the triangle is equal to 180. That also you can do. Otherwise, you can go with deviation angle. Exterior angle is equal to sum of internal angles. External angle is equal to sum of internal angles also. Okay, na? So then you can follow that out. This anything you can simplify. Then I can write down delta deviation is equal to I1 plus I2 minus of R1 plus R2. Minus R1 minus R2 is there, no? Minus of R1 plus R2. Then delta is equal to I1 plus I2 minus. In the place of R1 plus R2, we can write down A. So A is the angle. This is called as deviation. Deviation produced by the prism. Okay? Correct. If I1 is equal to I2, then deviation will become minimum. Minimum deviation will happen. Okay, na? So all of you see the angles. All of you see. We are using the two principles. One is opposite, sum of opposite sides. Sum of opposite sides in a quadrilateral is 180. The other one is total angle in a triangle is 180. Here also, total angle in a triangle is 180. Okay, so we are using the total angle in a triangle, total angle in a sum of opposite angles in a quadrilateral we used, nothing else. Clear? Understood? Surprisingly, same thing is there in your first standard also. But you will have more number of applications. You will go beyond this. Okay. Deputy completed, very good. Harsha finished that? Okay, Harsha. Completed. Okay, good. Finished? Very good. So finally, what we learned? So two things we learned. One is what R1 plus R2 is equal to A. The other one is deviation is equal to I1 plus I2 minus A. These are the two principles we learned, right? One is the angle of deviation, other one is the relation for R1 R2. R1 R2 you can say that angle is inside. Okay. Now, if you draw the graph between angle of deviation and angle of incidence, okay. So this is the prism, no? This is the prism. This is the ray. This is the perpendicular. Then angle of incidence is I. Then ray will come out, and this is the deviation, right? If you extend, this is called the deviation. Hope all of you are able to see the diagram. Okay, no? As I value changes, delta value also changes. Okay, no? As angle of incidence changes, angle of deviation also changes. No doubt. Angle of incidence changes, angle of deviation changes. Now I want to draw the graph between angle of deviation and angle of incidence. This graph has to be done practically, not theoretical. This is not theoretical thing. This is the practical thing. That means I have shown on prism now. This is the prism, right? This is the one prism. Like this, you have to take a prism and different lights and different angle of incidence. Then you will get different angle of deviation. Okay. So that you have to calculate. If you draw the diagram will be something like this. Rough diagram I drawn. So as angle of incidence is increasing, deviation decreases and then increases again. This is called graph. Graph between deviation and angle of incidence. So you will find the minimum deviation. Okay, this is called as minimum deviation, least deviation, when I1 is equal to I2. Whenever I1 is equal to I2, means angle of incidence and angle of emergence. Angle of incidence and angle of emergence both are same, then you will find the deviation minimum. Okay, that is an experimental graph. Experimentally only we have to find. When I1 is equal to I2, then deviation will be minimum. Okay, now we know that sine I1 by sine R1 is equal to sine I2 by sine R2. We know already I have given this principle initially. Sine I1 by sine R1 is equal to sine I2 by sine R2. This implies I1 is equal to I2. I1 is equal to I2 implies R1 is equal to R. By I1 is equal to I2. Then sine I1, sine I2 cancel out because I1 is equal to I2. Sine I1, sine I2 cancel out. Then sine R1 is equal to sine R2. Sine R1 is equal to sine R2 means R1 is equal to R2. That's why if I1 is equal to I2, then R1 is equal to R2. All of you understood? Sine I1, sine I2 cancel out. Then you will get sine R1 is equal to sine R2. Sine R1 is equal to sine R2 means R1 is equal to R2. Clear? Clear? So I1 is equal to I2, R1 is equal to R2. Now what we are doing is I1 is equal to I2 and writing as I. R1 is equal to R2 and writing as simply R. Okay? So if that is the case, then this value will become how much? 2R is equal to A, then R is equal to A by 2. Now deviation will become how much? Minimum deviation. That's all. I1 is equal to I2. Whenever I1 is equal to I2, deviation will become minimum. Then this is I plus I, because I1 is equal to I2, which are both are taken as I. I1, I2, both are taken as I only. Okay. Then minimum deviation is equal to what we can write down? 2I minus A. Then A on this side, minimum deviation plus A is equal to 2I. Then what is I value? Minimum deviation plus A by 2. So now I know the I value. I know the R value. Can you find out the refractive index? Vishwanath, yes, tell me. Vishwanath, unmute yourself. Vishwanath. Vishwanath, ready? Okay. So I know the I value, angle of incidence. I know the angle of refraction, R value. Can you find out V value? Yes, mu is equal to what? Sine I by sine R. Sine I1 by sine R1. I1 plus I. R1 plus R. Then mu is equal to sine I by sine R. Then mu is equal to sine I value. What the I value? I value is equal to minimum deviation plus A angle of prism by 2 by sine R value. R value is how much? A by 2. Then sine A by 2. So this is the standard formula for refractive index of a prism. Okay, na? So if you want to find out refractive index of a prism, there is one thing, that is you require the minimum deviation value by using this formula. Okay. So this is the standard thing what is there in your textbook. I think so. Okay, na? Copy this. In the next class we discuss much beyond this. Okay, na? We'll go little beyond this part, little beyond your textbook. You will understand better points than this. Okay, na? Just write it down. Okay. Dipti, yeah, time is going fast. Okay. Okay, good night, Dipti. So hope all of you wrote down, write it down in a proper notebook so that it will help you in the future. Definitely. Okay. All of you go through it again. Again, Vishnu Reddy.
Vishwanath, unmute yourself, ma. Vishwanath.
Okay, Vijay, good night. So already you are in bed, huh? Okay. No, okay. Just I'm joking. You send me the pic, no? That's why I'm joking. Vijay. So hope people didn't have your dinner. Have dinner and wait for some time. Okay, please don't watch mobiles before sleeping. Before you go to bed, don't watch mobiles. Okay, that will disturb your sleep. Definitely. Okay, so read something and go to sleep. No mobile. Very good, Vijay. Nice. Yeah. Okay, Partha, bye. So bye everybody. We'll meet in the next class. We will discuss much more than this. Okay. Yeah. So revise this part and come back to class. Okay. Bye everyone. Good night.